California's drought has led to a historic water crisis.
So this is our daily life, no water. You see it happening somewhere else, but not here in California. I mean, we're living it. We're not just seeing the drought, we're feeling the drought.
But California is not alone. In places like Haiti, the western United States, and parts of West Africa, natural as well as man-made disasters have contributed to a scarcity of clean, drinkable water. And that doesn't include places that are naturally dry, or places that can't afford to purify and deliver drinking water directly to people's homes. According to the United Nations, as of 2014, 700 million worldwide suffer from water scarcity. That's 1 in 9 people.
After 9 years of drought in northern Kenya, they're desperate. Villagers dig 6 feet below dry riverbeds, trying to find fresh water. Instead, a stagnant pool. So thirsty, they drink anyway.
But how do we make clean, fresh drinking water? Some areas have large-scale water purification systems, but these systems require a lot of power and infrastructure, like pipes and pumps, to deliver clean water to people's homes. Dry, rural, or poor areas, as well as areas hit by natural or man-made disasters, may not have this type of system. But everyone needs clean, fresh water to survive. Can you think of a way that places without these large-scale systems can make drinking water? Well, that's exactly what scientists like Kenny Stevens, professor of engineering technology at New Mexico State University, are doing.
These are 2 solar distillation units.
Made of simple parts like wood and plexiglass, a solar distillation unit, or solar still, can take contaminated water and produce safe drinking water in a short amount of time. How does a solar still work? It relies on the same mechanisms as Earth's water cycle.
It's kind of like what happens with rainwater. The sun heats the ocean, heats a lake, heats a river. The water evaporates up, it condenses into clouds, and when the clouds get to a certain size, it rains.
A solar still follows the same pattern of evaporation and condensation. Contaminated water is fed into the still. Energy from the sun is absorbed by the still's dark interior and is transferred to the water. The water evaporates and forms vapor, which condenses on the glass back to liquid water. Contaminants are left behind in the bottom of the still.
The little water droplets are kind of like the clouds, and when you get a water droplet of a certain size, it will drip down and start the whole process going.
The condensed water is then collected in a storage container.
It comes out about 99.9% pure. So you can basically take as junky a water as you can get and make incredibly pure water out the other end.
So how real is this solution? Already, communities surrounding the US-Mexico border and Cape Verde Islands off Africa have benefited from solar still technology. And at a cost of just around $400, a highly designed and well-built still can produce around 10 liters of clean water on a clear sunny day. But in an emergency, would that be enough? Go online and find out how much water you need each day to survive.